right, we were picking up on number 9. So we just graphed this into our y1, and I reminded students that if you're going to graph a sine curve, make sure you're in radian mode. All right, so we kind of talked over this is a sine curve shifted up 30, amplitude of 10. So we adjusted our window to be from 20 to 40 for the y-axis. And then looking at my possible answers, they're ranging from pi over 2 to pi over 40. So we adjusted our x window to just be from 0 to pi over 2. And then we can calculate the max. Okay, everybody good so far? Left bound. You should be getting this number. Right bound, enter. All right, here's what I want to show you. I think I've showed you this before. If you quit out of this screen, and if you use this button with X, and you hit enter, it'll tell you that X value you got from the maximum. Have I showed you that before? No? Okay. So you can use that. So then I'm saying from here, you're like, okay, is this pi over 10? No.
Can you do that again?
Is this pi over 20? I won't finish this. No. Is this pi over 30? No, we're getting closer. Pi over 40?
Yes.
Yes. Okay. So Brianna, after I calculated that maximum, you're okay with how I got that?
Yeah.
Okay, so the maximum, I just have to do it again. So see how right now it's in my X? So if you quit out of your screen and you just hit the X button, enter, it'll feed down that number. And that just gives you a visual to compare it to. Okay, so it's pi over 40. Now, really quick, if you were to sketch this, I think you could have got the answer quicker with our knowledge of sine curves. And this is a good review over sine curves. So this sine curve got shifted up 30, amplitude of 10. So it doesn't go higher than 40, lower than 20. I kind of like to do like this. This is my new midline, right? All right, sine curve, period, is normally 0 to 2 pi. So you take whatever's in the parentheses, whatever horizontal transformations they are, solve this for x, so divide everything by 20, and you get pi over 10. So that's 1 period for sine. Sine starts at a 0 or at a max? 0, ends at a 0. Halfway here, which would be pi over 20, halfway it crosses. So unless it's reflected, halfway is a max, halfway is a min, like so. So halfway here, pi over 40 would be your max. Okay, that's how you could do it without your calculator. All right. Next one. Oh, this is a fun little problem. So again, you guys know how to do this problem once I read through this. You know how to do it. It's just kind of connecting it with like an equation of a line. Like taking your knowledge of what you know about equations of line and connecting it with right triangle trick. All right, so it says in an xy plane, you have this line, okay, slope of 6, y-intercept of -3. What is the measure in degrees of the acute angle formed between that line and the x-axis? So let's draw a little sketch here. All right, y-intercept of -3. Slope of +6. That means I'm going to go up 1, 2, 3, 4, 5, 6 over 1. There's line L. So they want me to know what is a measure of the acute angle formed between the line and the x-axis. This angle right here, I'm going to call it theta. So what we can do, so you can draw a little right triangle here, and we can use trig to find that angle. Okay, so remember the slope of our line is 6. So I went up 6 over 1. So if I went up 3, that'd be exactly halfway, so this should cross at 1/2. And again, if you really needed to graph this, you could. But up 3 over half, up 3 over half would give me that slope of 6. So this length of my triangle, right triangle, would be 1/2. What would this length be? 3. Okay, so I know the adjacent and the opposite side. Which trig function should I use? Tangent. So the tangent of theta is opposite over adjacent. And when I don't know the angle, I use inverse. Okay, 3 divided by half, 6. My answers are in degrees. All right, got to switch my calculator back over to degree mode. I need the tangent inverse of 6. E. Okay. Again, you know how to find acute angles from a terminal side to the x-axis. We practice that a lot. I've given you like a terminal point. It's just connecting it with like a linear equation or asking it in a different way. Taking previous, oh no, I was just bragging about having one in a week. Okay. This question looks complicated and it's not bad.
It's like -9.
Exactly, yep. It's C. Why?
Because that's where the y-intercept is.
Exactly. You're given this big long polynomial equation, degree 4, positive leading coefficient. Okay, we can tell by the end behavior as well. And it's just asking what possible value could k be where k is your constant here. And while exactly correct, that would be my y-intercept. Which one of these looks like it could be probably the y-intercept? -9. All right, the next one's off your homework. I think I remember this. And it's one of my favorite things, transformations.
Not my favorite.
So we have a reflected absolute value curve right here. Okay, that would be a V shape reflected right now. They want us to first translate this 3 units to the left and then vertically translate this 2 units up. Okay, and then we'll tackle the next part. All right, who can tell me? So here's my starting function. How could I translate this 3 units to the left? Add 3 inside, right? That's a horizontal transformation. So, however you want to notate this. I'm just going to call it G for now. We agree that would shift it left 3. Okay, not done. Now I need to translate this 2 units up. How would I do that?
I put the +2 on the outside.
Yep, horizontal, +2 outside. Good. Now I just shifted it up 2. Okay, and then they ask us, so here's G. What's G of -2? Evaluate this one, X is -2. All right, absolute value of 1 is 1. The negative's outside times -1 + 2, 1. D. Ooh, the next one is a log equation one. Good. Good. I think, was it on the homework, this next one? I couldn't remember. Yeah, that's all. Okay, let's go over it together. So in this figure, we have a line L, and it passes through the origin, and it intersects this exponential graph. Okay, if I was given the equation, I know this is an exponential curve because the variable's in the exponent spot. I know it's an exponential decay because my exponent's negative. If you connect that with what you know about transformations, normally if my base is larger than 1, we have exponential growth. Remember that? Yeah. And this is just a reflection over which x-axis.
X-axis.
No, it's actually the y-axis. Sorry, I said the wrong answer. It's actually a reflection over which axis is what I was trying to say. The y-axis. So it's actually, now it becomes decay. All right, so that's that curve right there. They intersect at this point, a 0.4. What is the slope of our line? All right, so I just first figured out like where do these intersect, or what's my A value here? That's what I found first, because then it'd be really easy to calculate my slope if I know it goes to the origin. I would just do my rise of 0.4 over my run of whatever A is. All right, so if I want to know where these intersect, but I don't know the equation of the line, so I can't use my calculator, we're going to set them equal to each other. Like, when does my exponential curve, at what x value is this 0.4? I'm going to write it as a fraction, though, 2/5. Okay, with me, I'm trying to find A. If you want to change that to an A, you can. That would be less confusing. I want to know where this curve intersects my line at that y value of 2/5.
Could you plug this in your calculator so you don't know?
You could plug this into your calculator. You could plug this into your y1 and this into your y2 and see where they intersect. You could. I just want to review over algebraically how we solve exponential equations. But yeah, you could. You can't plug in the actual equation of the line, but you could plug in this horizontal line of 2/5 and see when that equals it. Good question. I didn't even think to do that, honestly. All right, let's review quick in case you have to do one of these on a no calculator, which would absolutely be fair game.
Wait, are you did 2 over 5? Is there
Do it to the
0.4 is 2/5. I just wrote it as a fraction. Okay, so right now my variable is here. It has 2 layers around it. The negative, I can't get rid of that yet. Log base. Oh God, I just said the answer again. With a base of 2, so I have to take log base 2 of each side. How you undo exponents is by their inverse, logs. Okay, I got to take log. I got to take log base 2 of both sides. Do you guys remember this? No? Okay.
Oh, then they cancel out.
Yup. These are inverse operations. These undo each other. I'd be left with negative x. This you can type in your calculator. Let's review over that. This was when I was on your practice. You do math, and then it's all the way down to alpha A, or you can just scroll down. So I need to know log base 2 of 2/5. Okay, I would just keep that number in there for now.
And then it's positive and 5, doesn't it?
Exactly. Yep. So the only thing we have left, so we have that long number divided by -1. Now, I'm not done. This is technically A, if you want to change it to A. That's the x coordinate of where they intersect. We just found that. They're asking me the slope of this line. So again, the reason they told you this goes to the origin is because now you know 2 points. So you just do rise over run. So my rise, or my y coordinate's 0.4 over my run is that x coordinate we found, that 1.3219 number. So since I have that decimal fed in my calculator, 0.4 divided by that number. Oh, I forgot to do the negative. It's the opposite of this number. Well, that just becomes a positive because you're dividing by both positives. So it's B. Okay. All right, so here I have a graph given to me. What type of graph is that?
parabola.
Quadratic. It's going to form a parabola shape. Yep. X squared plus bx plus c. I can't plug that into my graphing calculator because I have too many variables. It's symmetric about the line x equals 3. They're giving you the axis of symmetry. Symmetric about the line x equals 3, right? And it passes through this point. So what is the value of c? This is a happy face parabola. And they're telling me that the axis of symmetry is x equals 3. There's a couple ways you could do this. I personally would do this. Do you guys remember, like, because this is in standard form. So instead of trying to, like, complete the square with variables, a way we can find the axis of symmetry, and I remember teaching you this because I said do this with the word problems. It's a lot easier, is to use that negative b over 2a.
That's
Formula?
How the guy did it in the video.
That's how I got it in the video. That's how I usually teach it in standard form. I do. Negative b over 2a gives you the axis of symmetry. Now, the nice thing about this is I know what the axis of symmetry is. It's 3, and I know what a is, so I could figure out what b is. So you get 6 is negative b, so b is negative 6. I know there's not a lot of room to write here. So now I'm here. Now I know b is negative 6, so I just have to solve for c, and they gave me a point on my curve.
OMG.
So I could plug that in for x and for y, and then I could solve for c.
Wait, so how did you get the 1 again? The 2 times 1?
2 times 1. Oh, this is just like the form, or a is 1. So the formula is negative b over 2a.
So there's x. Oh, yeah, because a is the. Yeah.
Yep.
I forgot what that was for a second.
Okay. So when y is 2, or when x is 2, or when x is 5, I'm having a hard time talking today. I'm sorry. I haven't taught yet today. I think that's why. All my classes are like assessing and such. I got C to be 7. And that's what my answer was asking me to find was C. So that'd be negative 5 plus 2. Yep, 7. Okay. Here's some more exponential content for you. It's been a while since we've done exponential and logs. That was like chapter 3.
I don't remember anything.
So this is an exponential type of word problem here, and I know it's exponential just by looking at my equation because my t variable is in the exponent spot. So it says when a certain radioactive element decays, the amount in milligrams that remains after t number of years can be approximated by that function a of t above. Approximately how many years would it take for an initial amount of 800 milligrams of this element to decay to 400 milligrams? I remember there was like a problem almost exactly like this on your chapter 3 test. Does anyone remember what K, I know it's a constant, but like what that represents in context of my problem?
Something important.
The initial amount. Good job. The initial amount. This number in front is the initial amount. Now think why? Because anytime I plug in 0, what's anything, no matter what my base is, to the power of 0? 1. It's always 1. So your initial amount is always going to be 1 times this number. Initial amount being like at year 0. So this number right here. Good job, Megan, that you remembered that.
I'm so proud.
I used to be good at this stuff.
Thanks,
I
Tyler.
don't remember.
Is your initial amount. So if we have 800 milligrams, I'm going for my initial amount. Yes. When is my amount going to be 400? If you don't know how to solve this, you could plug this into y1, y2, find where they intersect. Okay. If you're in a panic and you just draw a blank. We're still on the calculator portion, right? Yeah. So you could do that, but again, for sake of let's review logs and stuff. Connor was exactly right. So I just have a few layers around t. So first I get rid of the 800. So I get 1/2. Yep. How do I get rid of base e? ln both sides. Good. I know. Everyone thinks that it's ln, natural log. That undoes the base of e. So I have the natural log of 1/2. I'll plug that in my calculator in a second. But all I really have left to do is divide off at negative 0.001. Remember, I always made you write your answer both ways. I made you write this and then the decimal.
Oh.
Because this is one quick, easy way to type this all in your calculator. The natural log of 1/2 divided by negative 0.001. So that would be C. 693 years. C. Okay, the next next one's a cute little problem.
Let's graph it.
Okay, I have a piecewise function here. Yes, you could graph it. On your graphers, let's try that. I think there's a way, let's see if I remember how to do this, to graph like just the piece you want. So first of all, make sure, because the first one's a sine curve, I gotta switch over to radian mode. Let me see if I remember how to do this.
There's a piecewise there in that. All the way down by log base.
Oh, let's try this. 2 pieces, please. Okay, let's try this. 3 sine of x x. All right, if you go second test, you can get inequalities. So second math. Okay, I have never used this tool before. I'm hoping this works. I'll show you again. All right, so remember, use this button. So to get to those inequalities, you hit second math, and it should pull up these.
I don't have that.
You don't have these inequalities?
No, I don't have the piece.
The piecewise one? Okay, I think there's another way you can do it. Hold on. Let me just see if this even works. Oh, my window's probably on.
I have it.
Hold on. I'll show you. I'm pretty sure there's another way to do it, because I used to have the old school calculator too. Oh, it worked! Okay, so I think this is the other way you can do it. I think you can just type in like 3 sine x and then do second fancy bracket. I don't know if you need a comma there. We'll find out.
Yeah.
These things are amazing.
X
Oh.
is less than 0. I think you can do it this way. Let me just try if it'll work. Why did it grab?
So this can this solve inequalities for you?
We didn't do this for.
You can like change, like this can graph inequalities. Like I think you can change this equal
that's
sign.
cool.
I think you can change it. There's a way to change it to an inequality. You have to have something turned on, I think. This worked though. I don't know why it did graph this piece though. Let me try entering a comma. So if you don't have the piecewise option,
Let's see if I can do this.
you just use the fancy bracket for the x values you want. Nope. No,
I got
no
it.
comma, no comma.
Mine worked.
Okay, and then you just type in the other piece.
No.
Fancy bracket
Shut up.
x
Wait, is it in?
is greater than or equal to 0.
I don't know how
See, I'll remember that.
Don't worry, that's what matters.
That should work.
Oh, you have to do the
Wow.
separate line equals.
These are the same color. I hate that.
Yeah.
Yeah, you have to do 2 separate ones.
Can you copy and paste on this thing?
No.
Unfortunately. Maybe you can on the computer.
I just don't know why it's graphing this extra piece, but use your knowledge and know it's only when x is less than 0. Okay, so anyways, we're asked to find the range here. So we know our sine curve has an amplitude of what?
3.
3, so it's not going to go higher than what number? 3, and it's not going to go lower than what number? Negative 3. So I know the bottom value of my range is negative 3. Now this only goes high to 3, but think this one goes on forever, right? So a square root curve.
Yep.
So it'd just be all numbers greater than negative 3. Is that option A?
A.
Now, if you're running low on time, I think we could have all quick sketched this curve pretty easily. Square root of x, anytime x is greater than or equal to 0. And my sine curve with an amplitude of 3. So that would normally go this way, so it'd be something like this. So I know it doesn't go lower than negative 3 or higher than 3. we probably could have quick sketched that one, but if you have time to type in your calculator, you can do that. All right, next one. I feel like we should move on to some no calculator ones.
Oh, come on.
Or do you want me to keep doing these?
Yeah, these ones because they're way hard.
Actually, yeah, that's true.
Can you tell Larry?
Okay. So my function h above gives the height above the ground in feet of a passenger on a Ferris wheel t minutes after the ride begins. During one revolution of the Ferris wheel, for how many minutes is the passenger at least 100 feet above the ground? Round your answer to the nearest hundredth of a minute. Okay. So I started by just figuring out, okay, when is my height 100 feet? And I use my calculator to do this. I plugged this into y1. No, actually I did this one to y1, so I did. It doesn't matter. I plugged my function into y1, and I plugged this into y2. And essentially, folks, what we're going to find is when my curve is greater than or equal to 100. Okay? So I want to know when my height, which is modeled by this, is at least greater than or equal to 100 feet. So in my graphing calculator, I'm just going to graph these two. So let's start by typing in that bad boy cosine 1. 64 minus 46 cosine pi over 5, wrap that in parentheses, x. And 100. All right, so obviously I'm going to adjust my window here. What's my time ranging from? 0 to 10 minutes. So that's how I'm going to adjust my x. I'm only looking from 0 to 10. If you want to go a little bit, if you want to go to 11, that's fine, but I can't have negative time. And then I'm trying to figure out when this equals 100. So I'd maybe start it at like 90 and go all the way up to, 150, because it can be greater than or equal to. Okay. So here's my time when my height, which is modeled by the cosine curve, is greater than 100, or at least 100, right? In this span. So we'll figure out exactly when it equals 100, and then it's just the minutes between those values. Does that make sense?
What can you just do the intersects?
Yep.
Subtract them?
Yep, exactly.
Nice.
That's exactly what we're going to do. Second calc intersects. So let's just do this first one. And I do want to show you one other thing too. Okay, it's not a nice number. So because we have to find two of these, we can store this number. I've definitely showed you this before. So quit out of here. Let's hit X, hit enter. Let's store that as A. You guys remember how to do that?
No.
STO, store, and then whatever you want, alpha A. Now it's stored as A. Kind of like your matrices, how it stores it as matrix A, matrix B. This is just storing it as a value. You don't have to do that. If you just wrote down the approximation, that's fine too. But the reason why is because now I have to calculate a second one. Second calc intersect. When I calculate this one, and I go to type in X on my home screen, it's going to take the most recent X value you have. So now when you say, okay, what's X? It's now going to take the one we just found. And maybe I want to store that as B, but all we need to do is subtract the two. So I just need to take this one minus, and you could page up if you wanted to, or minus what we stored A.
How'd you just do that? How'd you go back though?
How'd I hit A?
Did you just put alpha on that?
Alpha A. Yep.
Oh, it's alpha.
The green button?
It's just to get to the green numbers, the alphabet numbers on here. Yeah. We also figured out, and I think I still want YouTube to practice using the calculator at some point.
Alright,
I don't know. Are you guys going to come into the RTA tomorrow?
maybe.
If not, I can give you the link and you can do it on your own.
Alright.
But we figured out, was it you that figured this out? On your keypad, like if it's kind of confusing, so if you're just a clicker, that's fine. But like if you want to type a parenthesis, we could just hit the K on the keyboard, right?
Mhm.
Like the numbers on, or the letters on the keyboard matched with the alphas. So I think, like, for example, if you wanted to hit minus, you could just hit W, and it would do minus. We can practice using those again, but all right, let's keep going here. So that one I got, it said round to the nearest 100 at 2.14. For how many minutes? 2.14. All right, this one's kind of annoying because you really have to zoom, but it says how many different values does it satisfy that this equation equals this equation? So again, I would just type this into y1. I'm not actually going to do it because we've done a couple of these. Look for the intersect. I'm just going to warn you. Is this one on your homework?
Yep.
Okay, perfect. You really have to zoom in to see all these.
Yeah, one of them was like really close, or two of them were really
Yeah.
close to the origin.
Yeah, and it's like, does it cross and then it cross back over? You really have to zoom in. It ended up being 5. I feel like it looks like it could either be 3 or 5. So then that'll hint to you, like, really zoom in and see if it does cross twice there. And yeah, it's really close to the origin. Okay, one last one. I do want to go over this ball bounce one. This one was on your homework.
Oh,
I hated this.
Yeah, these ones you haven't done before.
Yeah, they're confusing.
It's just not in your guys' curriculum. So this isn't too bad once you look at if you can notice patterns. So we have a ball dropped from an initial height of d feet above a floor, and it repeatedly bounces off the floor. Each time the ball hits the floor, it rebounds to a maximum height that's 3/4 the height from which it previously fell. The function h models the maximum height in feet to which the ball rebounds on the nth number of bounce, which of the following could be an expression for h of n. All right, so just to give you a little visual here, this height we're calling d, and we're dropping a ball. So we drop the ball, it bounces, and then it bounces back up to 3/4 of its height that it fell from. Same thing, 3/4 of that height, etc. So this height is 3/4 of d, the distance it fell from, after my first bounce. After my second bounce, it's 3/4 of this. 3/4 of the previous, the 3/4. This is called a geometric sequence. You guys don't do sequences in series, but next one would be 3/4 of this. Now, obviously, you could simplify this if you need to, but we're really just looking for, like, what's my pattern here? So this is after my first bounce, second bounce, third bounce. So you can see here, I'm just multiplying by another number of 3/4 each time, right? So if n is like my number of bounce, after my first bounce, it's just 3/4. After my second, it's 2 factors of 3/4, or 3/4 squared, 3/4 cubed after my third bounce, so it's a. The 3/4 is what's, so another way you could show this, like, after my first bounce, that was my height. After my second bounce, it's 3/4 squared. After my third bounce, 3/4 cubed. So it'd be that would work. Okay.
Okay.
Those are all the calculator practice ones. As I mentioned, I think these problems are a lot easier, so you should have dipped into some of these with your homework assignment last night. If you're not keeping up, good luck doing 65 pounds in one sitting. All right, here's the equation, and it just asks, what's the value of x? I have a conjugate here, so this multiplies out really nice, because the outer and inner total what?
0.
0. That's a third pattern of conjugates, right? I get √5x minus √5x, so I really just need to multiply the first and the last. D.
Oh, I guess.
This is not
That one was?
all of these. So was the next one.
Huh,
Okay.
lame.
We just did.
Literally, they have 2 practice tests and they recycled the same problems.
Pretty much.
How lazy, CLEP.
Does that mean on the actual
Get your
prep
claps
exam
together.
will we have questions from our homework?
What?
That'd be nice.
I hope not.
I didn't hear what you said.
I hope.
Okay, here's a classic fog problem.
this is the only one.
Fog, f of g of x. Yeah, it is easy. So that means he's gonna take g of x,
6.
and you're gonna plug it into f, which is 2x plus 1. See. Okay. 22 is like a classic like conics problem. See if you guys could recognize this. Which of the following equations could be a parabola?
B. No, not B.
If x and y are both being squared, it's either a circle, ellipse, or hyperbola. So I automatically know it's not these.
B.
It is B.
B.
Is B?
Yeah, it is B.
You
Boom.
just switch the.
If you were to solve this for y, yeah. So the classic like rule with conics for parabolas is one of the variables is being squared, either x or y. It's kind of the rule.
What if y squared?
This
Neither
one
of
was
them are
Anna's
It doesn't
thinking
matter as
too.
long as X is.
Yeah.
This one is on your homework too.
Yep.
Alright. An experiment designed to measure the growth of bacteria began at 2 p.m. and ended at 8 p.m. on the same day. The number of bacteria is given by this function, exponential function. T represents the number of hours that have elapsed since the experiment began. How many more bacteria were there at the end of the experiment than at the beginning?
Plug 0 and then plug 6 and then subtract them.
Okay, exactly. Well, to find my beginning, we could plug in 0, but what's my initial amount here?
1,000.
1,000. Okay? But if you plug in 0, you're going to get that same thing. My end at 8 p.m. would be after 6 hours.
3 to the 4th times 1,000.
Yes, that ends up being to the 4th. Yep, I'm just going to show this. Now remember, we don't have our calculator, so we got to do this all by hand.
It's times 1,000, right? Not 100.
Oh
Yeah,
my god, I'm
I
so
think
smart.
There you go.
I did it.
That ends up being 4. Do you guys know what 3 to the 4th is?
81.
81.
Nice.
81.
So it ends up being 81,000.
Wow.
So 80,000 more.
Wow.
You guys say you don't know how to do these.
It's
Well,
because like I
We
don't
didn't know how to do
start.
the calculator ones. We
Well,
know how
I
to do
know how to
these ones
start
though.
Yeah, the math is easy. It's just starting
this was
from
on
the
the
words.
homework.
Yeah, it's
that I
just-
did it.
Getting used to the what they're actually asking you to do.
Alright, I don't have time.
Yeah, sorry.
Oh yeah, the next one's real quick. Okay, this is just a linear function. And they're giving me this equation. Ax plus b. A is my what? And b is my y-intercept. Which of the following is always true?
Less than
Is
0.
my slope positive or negative?
Nah, that's not good.
Positive. Is my y-intercept positive or negative?
Negative.
No, pass.
Y-intercept is negative.
Negative. All right, so when I multiply these together, am I going to get a positive or a negative product?
Negative.
Negative. Okay, so that's looking good. It's not going to be positive. It's definitely not going to equal 0.
It's A.
They're not the same. Yep, it's A.
Swag, you're so smart.
What's our homework for tonight? 35 to 50?
It is
The rest of them.
Yeah, just do the rest.
35 through 50.
Yes.
And then for Thursday, it's 55 to 65. All right, so you two that were gone, Connor,
Yeah.
I linked. Here's the calculator practice. Now, if you have a Chromebook, it doesn't work on a Chromebook.
Well, that's
So you either have to. We went to the library,
okay.
or if you have a. Do you have a Mac, Natalie? I feel like you have a Mac. It will work on there. So you just go on here, you select pre-calc test, and it doesn't give you like practice problems. It just like says practice evaluating e to the 6th, and then you can show the answer. There are a couple. If you see one that says something about regression, like I think it was like 2 or 3, we skipped those ones. Ones you don't need to know how to do. But it's just practice using their
And
calculator.
step. And
Oh
step.
shoot! I gotta stop the recording. Just do that.
2.5
Excuse me, my
credit.
friend.
It's a silly schedule. That's 10 minutes.
So are we gone?